Hey, so good morning. We are going to finish up Chapter 6 today, and we'll also review for your next exam, which will be on Wednesday of next week. Was it October 28th, I believe? Maybe 29th. Yeah, October 28th. I think I told you I'm going to New Jersey. I won't be here Wednesday. I won't be here Monday either. So we're going to review for the exam today. But there is one other thing that I'd like you to do Monday. Basically, we're talking about the network and the infrastructure and the internet. There's a really nice video. It's kind of an old video. It's called Marvel's, the Internet Behind the Web. I want you to watch that for Monday. So we'll talk about that in a minute. So we're talking about networking in the cloud. And we did a lot of work on understanding this thing called a local area network and some of the components of it, how things communicate across a network and the internet. We talked about the protocols that we use. We spent a lot of time last class talking about how the internet works, what the unique address is, called an IP address. We talked about the domain name system a little bit and how things actually come together. Okay, so two concepts that I kind of want to talk about today, and that is, when all these things come together, we talk about a three-tier architecture. Okay, so there's really three things that have to happen for us to be able to use the internet. And the first one is the user tier, and that's the one you're working on. That's the one you're familiar with. And the user tier would be an example like your web browser is the user tier. So you have a browser that does a couple things. You can enter in a URL in that browser, and it goes out and requests, a certain resource, some server somewhere, some folder, some file, and it brings it back to you. The other thing the web browser does is it converts, HTML or whatever language into what you see, right? So the file on that server is HTML. It's HTML5 or JavaScript or something like that. And your web browser does a nice job of converting that to what you see, the pictures, the words, the forms, all those things. Now, what you're connecting to, we kind of covered this already, is that whole infrastructure of the network. And somewhere there is a web server, a commerce server. This is the server infrastructure that you don't really see, you don't really care about. It's out there in what we call the cloud. The servers for St. Francis are like there's a server room up in the floor above us in SCOTUS. But you could go 4 years here, 20 years here, be an employee here, and never know where those things are, right? And never care about them because they're maintained by someone else. And the third thing, which kind of dovetails with what we talked about last class, is the database tier. Okay, so a lot of web applications serve dynamic pages. For example, if you look at Amazon, any product on Amazon kind of looks the same way. What does it look like? If I look at the page of an Amazon product, what does it look like? What was always right here? Yeah, we always see the picture of the product, right? What goes alongside of it? Yeah, there's pricing, the stars are up here, then there's a description of the item, right? It kind of follows the same format, right? Because every product page is just that. It's like a template. So when you call up and you want to see, you want to see something about, Bose speakers, what it's going and doing is it's going to a database and saying, hey, we want product number 1734. And it retrieves from that database the picture associated with product 17134, the price, the comments, right? So it's all tied to a database. So someone at Amazon isn't building a page for every product. They're entering the information into a database. That database is utilized to dynamically build that web page. Does that make sense? So all those comments, when I comment, that's building something in a database, and then it gets displayed. So all three of those things come together for us to be able to browse the web, for us to be able to see various products. And it's called the three-tier architecture because all three things have to come together. Now, the last concept in Chapter 6 that I want to talk about is we talk about this thing called the cloud, right? And we say it's kind of hard to point to. That's the cloud. It's kind of a nebulous thing. And what it's led to in the business world is we use the cloud. We use services in the cloud that, we don't know where they exist, but we say we can use them. And some terms, some good business terms business people need to know is if we're using software in the cloud, we call that software as a service, right? It's not software that I have to install on my computer. It's software that I go out to the cloud and use it as a service. If you look at, Office 365, which is the online version of Microsoft Office, you're not installing that software. You're going out to the website, to the cloud, and saying, I'm going to use this software just as I would use Microsoft Word, Microsoft Excel. I'm using it as a service. Salesforce.com, which is like an enterprise resource planning, customer relationship management software. Basically, we don't have to install it. We just say, we're going to start utilizing it. We're going to buy a license to it, not a license, but a subscription to it, and we're going to start using that software as a service. iCloud is another example. So the software itself, we don't have to install it. We don't have to maintain it. We use the software as a service in the cloud. Does that make sense? So organizations do that. And what's nice about that is because it's in the cloud, I can install it, use it instantly. Now, some companies want a little more control. They just don't want to say, I'm going to use your software as a service. So another layer down is platform as a service, okay? Platform as a service. So what this is that says, I'm going to use a server, okay? I'm going to use an operating system that exists at some server farm somewhere, and I'm going to use their platform, and I'm going to install my own applications on it. Like maybe I develop my own application, so I want to use that software, but I want to install it on a platform at some server farm that I lease, right? So that's called platform as a service. And finally, the last one is the most, most rudimentary is infrastructure as a service. So in infrastructure as a service, it says I'm just going to lease, databases. I'm going to lease storage. I'm going to lease, maybe an operating system in the cloud. So it's just like the bare bones of what it is. It's called infrastructure as a service. And a good example of this is Amazon. Amazon, you know that they sell products, but they also have a huge, huge infrastructure of databases and servers. And those things aren't always pegged. They're not always utilized. So what they've done is they've built services where you can lease Amazon services to use for your business. So it's very scalable. So software as a service, platform as a service, and infrastructure as a service. This is one where everything is provided to you, okay? Like Salesforce.com, Office 365. And this one is where you're just basically getting the machine, right? You're getting the machine connected, so everything is on that scale. Okay, so that is the last concept of Chapter 6. There's some other things in here, but I'm not really going to go through those. So that kind of concludes Chapter 6. Any questions on the cloud, networking? All right, so let's talk about your exam that'll be on Wednesday. If you go out to Blackboard right now and go under MIS102 and under Exam Review Documents, you should see a document that says Exam 2 Review 2015. All right, so the format of the exam will be closed book, closed notes. It is Wednesday, October 28th, so during class time I won't be here, but my GA is going to proctor it. It's a 50-minute exam, 100 points. There's 35 multiple choice, worth 2 points each, and 4 short answers worth 7.5 points each. So that's where the 100 points comes to. The chapters that are included. The first chapter we talked about, this kind of seems like a long time ago, I don't know why it does, but it seems like a long time ago, was hardware and software. Okay, so hardware, remember we talked about the 5 component framework, hardware, software on the far left, that's kind of where we started. And we talked about basic hardware components like input devices, output devices, so keyboards, hard drives, those kind of things, storage and output. We talked about types of memory, RAM, random access memory. Is that volatile or non-volatile? You guys remember talking about volatile versus non-volatile storage? Volatile means what? Yeah, if you lose power, it's gone, right? It's kind of temporary. Non-volatile means it's stored, like on a magnetic disk or on an optical drive, on a piece of paper. That's non-volatile. So we talked about central processing unit. There might be one multiple choice on binary, okay? And basically it'll be something like this. And so you should be able to do this. If I say, what is this in binary? Okay, and one of the answers will be 11. That's not 11, right? So what would that be in binary? Remember, binary is base 2, so this is 2 to the 0 power, 2 to the 1, 2 squared, 2 cubed, which is 1, 2, 4, 8. So this bit's on, this bit's on. So what does that mean? This is in decimal. It's 3, okay? 2 plus 1 is 3. If I turn this bit on, now what do we have? 1 plus 2 is 3, plus 8 is 11. You guys remember binary? Yes? Okay, so there'll probably be one multiple choice where I'll give you something like this and say, what's the decimal representation? What's the base 10 representation, right? You can do that? So one multiple choice problem. One thing I do want, and I want you to understand what ones and zeros are, like what binary is. It's ones and zeros. And I do want you to understand the basic structure, how that all comes together, so we can represent pictures and audio and video and all those good things. It all comes down to storing those ones and zeros. I do want you to understand the prefixes, right? It's important that you understand the prefixes because, like I said, you might say, oh, what's the difference between mega and a giga, or mega and giga? And you're off by not just like a few, you're off by a power of 1,000, right? So it's significant. Understanding that mega is like 1,000,000, that's important. Okay, so we talked about bits, bytes, kilo, mega, giga, tera, peta, exa, and I'm really more concerned with giga and dot. Those are the ones we currently work with a lot, right? So to know that a gigabyte, how many bytes that is. I know what a megabyte is. A megabyte is 1,000 kilobytes, right? That's important. So that'll be in the multiple choice as well. Okay, so please know those prefixes or understand those prefixes. We don't know what magnetic disk versus optical disk are, just different ways of storing ones and zeros. Magnetic disks store ones and zeros as the magnetic direction. Optical disk, I think we talked about this. When you burn a CD, burn a DVD, shines a light down, that's why it's called an optical disk. If the light shines back, it's a 1. If it doesn't shine back, it's a 0. Remember we talked about that? Client-server applications, we talked about thin versus thick. Operating software versus application software. So some examples is Android. Is that operating system or application software? Android would be an example of operating system software. Excel is an example of application software. And we talked about application software. We went a little further, it's kind of down here, but we talked about horizontal, vertical, and one-of-a-kind applications. So horizontal means what? Horizontal applications means what? That's definitely going to be on there. A few multiple choice, maybe even short answers. That's an important business term. It's not just in IS. It's horizontal. Across various industries. Like email is used across healthcare, finance, education, right? Spreadsheets. Those are horizontal type applications. Vertical is geared toward one industry. For example, Blackboard is vertical software, right? If I have a system that keeps track of dental records. That's vertical software. Okay, one of a kind is something very, very unique. We talked about open source software versus proprietary. Proprietary software is copyrighted, meaning they say this is the things you can use it for and things you can't use it for. Open source software, the source code is made available. We're allowed to use it freely. We're allowed to add to it. We're allowed to update it. All those good things. There's some advantages and disadvantages we talked about of using open source versus proprietary software. You guys remember we put those on the board. That's important. We talked about licensing, right? When you buy software, you don't typically buy the software. If I own Microsoft Office, I'd be a billionaire, right? So I don't own Microsoft Office. I own a license to use Microsoft Office. We talked about enterprise licenses, meaning everyone in your organization can use that software. Seat licenses are limited, right? We say maybe 25 people can use that software, or 50 people. It goes by seats. Software has upgrades. Typically, when they license it, they also, like enterprise level software, you license it, but you also maybe pay an annual maintenance fee so that you can call someone if something breaks. So that's part of the deal. We already talked about types of software, horizontal, vertical, one of a kind. And that kind of relates to how we acquire software. If it's horizontal software, we usually just buy it off the shelf, right? If it's horizontal software, it doesn't really add any competitive advantage for our business. We just buy it off the shelf and don't really do much with it. It's email. We just buy it. It's a commodity item. If it's vertical software, we do typically buy that off the shelf, but we may make some customizations or alterations. For example, we bought Blackboard, right? But maybe we put, the St. Francis colors on it. We put, maybe there was a certain course template we designed into it, but we bought that software, okay? Now, if it's one-of-a-kind application, well, you really can't buy that because it's unique. It's one of a kind, so that means custom developed. And I think when we spoke about that, I used like the suit example, right? Which one's cheapest? When you buy like off the rack. That would be off the shelf. You just buy it, right? Someone developed it. They say it's a commodity. You use it. Off the shelf with customizations or alterations might be, you get the pants, the hem taken up in the pants, and maybe the waist let out. And then finally, the last one would be like a custom tailored suit, right? The most expensive option. So in the business world, typically we acquire most of our software, off the shelf, right? Why? St. Francis, we're not a developer, so we buy most of our software, right? It's not something that's not our competitive advantage. It's not how we compete, so we buy our software. When we talked about this software, it kind of relates to the cloud. What's a thick client versus a thin client? What's a thick client, versus a thin client? Client is like what you have running here. This is the client you're using, the user tier, if you will. What's thick versus thin? Yeah, like when we talk about software as a service, okay, what do I need to use iCloud? All I need is a browser, right? So that means I don't have to have a lot of things installed on my laptop, right? All you really need is a browser. It doesn't have to have a lot of processing power. All that's happening in the cloud. So that's a thin client model versus installing something right on your machine and having it do all the work. For example, when you guys access GroupWise, you use the webmail version, right? That's a thin client kind of version, right? All you need is a browser. You can do it on your phone. You can do it on your laptop. We can also install the thick client version of GroupWise, which means all downloads on your computer. It's sorted there. It's stored there sometimes. So that's thick client when you need more processing power. So that was chapter 4. Things real important there is understanding the types of software, how we acquire software, the vertical, horizontal. All those kinds of things will be tested for sure in the multiple choice. So before we close out chapter 4, what questions might you have, or what on that list might be you can't remember, or we're having trouble understanding when I explain it? Anything? Sarah, go ahead.
The client server applications versus the thick and thin. Is that just what the client is?
Yeah, those. I'm glad you pointed out, those two things are related, right? A client server, so this is your client, like you are the client, okay? So client server model is that some things are done on your machine and some things are done at the server level, right? So those two things are definitely related. When you're talking about a thin client, you're saying, you know, most of the processing power is happening on that server side or that cloud side. You know, most of the software is installed there. When you're talking about, you know, most of the things being done at the client side, we call that a thick client. So you need a more robust machine. So those two things are very, very much related, right? The client server model is just saying that you have something on your machine, which in the case of thin client is just a web browser, and you need to access something, some server somewhere in the cloud, in SCOTUS, wherever it might be. Okay, that's all the client server model is. So that's a good question. So yeah, those two things are really kind of tightly related. What else? Anything else in chapter 4? All right, let's look at chapter 5. So chapter 5, we spent a lot of time in chapter 5, is understanding databases. And one of the first concepts we talked about is, why do I need a database versus just a list? A list would be just a two-dimensional list that you could put on a piece of paper or in a spreadsheet. Why do I require a database versus a list in the first place? And we saw how that breaks down. A list breaks down if we need what? How they're linked together. Okay? When we need to link things, when we were trying to store information about multiple things, right? We're just storing information about student grades. Yeah, a list works fine, but now if we're trying to store things about student grades, student office visits, student residence, that kind of thing. Now we need to link things together through a database, right? That's the purpose of a database. So one of the things that's really important to me is that you can name like the hierarchy of a database and how things come together. So the database, if you recall, the definition for a database was it's made up of tables and relationships and metadata, right? There's a slide that says database is tables, relationships, and metadata. So metadata, if you recall, is data about data. It's a description of the data. So when we talk about the hierarchy of a database, the highest level are those tables. We built some tables in this class. I didn't grade those yet, by the way, but I will. We call those tables entities or files. The next level down is there's rows or records. So in this tables, there's going to be a student record for Elena, a student record for Aaron. Okay, so those are called rows or records. Those records or rows are made up of fields or columns. So in the Elena row, we store her GPA, we store her address, we store, we define these fields when we built the table. Those fields are made up of characters. If her GPA is 3.98, 3 is a character, the decimal point's a character, 9's a character, and those characters are made of bytes and bits, right? Bytes go down further level bits, but we really only kind of talked about up to the character level. Data types. When we built our database, there were different types of data. We could store things as text. We could store things as integer. We could store things as currency, date, time. Those are types of data. Okay, that's data types. We build that structure. Really want you to understand, the database form that we use with Access, that we use with Oracle. We didn't use Oracle. With DB2, with all the major databases, something called a relational database model, where we have these tables, they're related together. How they're related together? We're through the keys, right? Primary keys and foreign keys. A primary key is the unique identifier for a row or record in a table. The foreign key is when we relate those tables together, the foreign key points to that primary key, right? It is in the foreign table, but it references the primary key, so understand that. We talked about the database management system, which is really the software around the database, and allows us to do things like forms, reports, queries. Remember, a query is a question. And also, we talked about queries. The language we use to communicate to the database is something called SQL or SQL, which stands for Structured Query Language. So that is important to know. And we talked a little bit about these forms, reports, and queries coming together to allow us to build applications that utilize the database. So that was chapter 5. And I think we spent a lot of time in chapter 5, and I think we applied it a little bit when we talked about access. So hopefully that's pretty clear to you. Any questions on chapter 5? All right. Now let's move to chapter 6, which we just covered, so that should be the most fresh in your mind. So a couple things we talked about. And I don't know, maybe I didn't highlight this enough, but Metcalfe's law, okay, it's not in your book, I don't think it's in your book, but it says the usefulness of a network is n squared, where n is the number of users. And remember, if it's just a network, like, if Facebook had 5 users on it, well, it's somewhat useful. I can be friends with these 4 people, but it's highly useful because there's millions of people on it, right? If eBay had 2 buyers and 3 sellers on it, it'd be kind of useful. But because the number of users increases, the network becomes much more useful. If the internet, connected 5 slots like it used to when it first started, 5 spaces, it'd be somewhat useful. But it connects every aspect or almost every point in the damn world, so it's highly useful. So there's an exponential usefulness of the network for every additional node we put on it. So Metcalfe's law says the usefulness of a network can be calculated by n squared. Just saying, it's exponentially grows. Add a user to it, it doesn't go up a little bit, it goes up a lot. Okay. We talked about LAN and WAN. What's the difference between a LAN and a WAN? Local area, wide area. What's the difference between a LAN and a WAN? The major difference. Eric?
Like a LAN network, you can control the wiring, you can control what building it is.
Yeah, if it's in one building and we own it, right? We're the ones doing the wiring, right? If it's a wide area network, well, we don't control from here to Tennessee, so we're going to have to lease a line from a company like Sprint or Verizon. That's usually it's optical fiber, right? Because it goes really, really fast. We talked about the internet and internets. Internet is a network of networks, and the internet is the internet. It is the network of networks that we call the public internet, right? Because that's what we all connect to. There could be, I could have in my house a network of networks if I was so inclined, but it's on internet, but it's not the internet, right? The internet is the public internet that we use. We talked about NICs. What are NICs? Network interface card. In your computer in your laptop, you have a wireless NIC and a Ethernet NIC, right? So that you can wirelessly, your network interface card takes care of the 802.11 that you're communicating to that access point. The Ethernet 802.3 is when you plug in, that takes care of that communication. And as we talk about that, we said everything in a network goes back to a switch, and if you think about a switch, it basically just has a bunch of ports on it. When I plug in, when I hardwire with Ethernet 802.3, I'm actually creating a physical connection from my port in my wall to my computer the whole way back to the switch. Someone ran cables the whole way back to that switch. It's usually in a closet, like in a dorm. Okay. When I connect to the access point, that access point has a wire that runs back to that switch, right? I connect to that access point. That access point is taking my protocol 802.3 or 802.11, known as Wi-Fi, translating it to 802.3, going back to that switch. So when you plug in, you get your own little port on that switch. When you're using the access point, you guys are all sharing that port, right? So you're talking to that access point, which is going back to that switch. A MAC address is, I don't know if we talked about that much, but every device on the internet, this is different than IP address. IP address can change. MAC address is hard-coded on the network interface card. So if you're connecting with your wireless interface card with 802.11, your MAC address is like embedded in that access card. So it's always there. It doesn't change. It's not dynamic. Protocol is basically, we talk a lot about protocols. basically the language, right? The rules for how we're going to communicate is called protocol, optical fiber. The speed of connections, when we see, and I don't know if I pointed this out, a little b means bits. A big B, a capital B, means bytes. So usually when we talk about storage space, we talk about megabytes and gigabytes. We're talking about bytes. When we talk about speed, like transmission speed, which is usually lowercase b, we're talking about bits. So we're saying 600 megabits per second. So 600 million bits per second can go through that connection. Okay, or that's your download speed. So little b is bits, big B is bytes. So a lot of times we're talking about kilobits per second or megabits per second. Protocols that we use, 802.3 is a standard known as Ethernet. 802.11 is a standard known as Wi-Fi. Talked already about an access point. ISP, we talked about what are the three major flavors of internet service providers that you could use in your home network, your small office or home network, based on the provider. Cable, DSL, what was the other one? Wireless or satellite, right? Wireless or satellite, those are the internet service providers. Modem stands for modulate, demodulate. It's that device that takes that signal and translates it for you. We talked about packet switching when we sent a message from JJ back to Eric. Those are packets. We talked about routers are the traffic cop of the internet, right? They're the things that route things throughout the internet. TCP/IP is the protocol that's used. Have you ever seen this term? It's voice over IP. That just meant to show you, when we have phone conversations over the internet, that's called voice over IP, because IP is the internet protocol, it stands for internet protocol. We talked about domain names, right? Domain names are basically human-friendly names given to addresses on the internet. So francis.edu is really maybe the IP address 168.42.32.156, right? Domain names are us giving a friendly name to it so that we can use it, remember it, brand it, because we don't think in terms of dotted quads, right? So that's what a domain name is. And domain names have an aspect of it called the top-level domain name. So if I were to reserve miko.com, the .com is the top-level domain name, okay? There are generic top-level domain names like .com, .org, .edu, .net, .gov, .mil. Those are generic. And the other type of top-level domain names are associated with countries like .ca for Canada, .uk for England, the United Kingdom. So those are generic and country code top-level domain names. Talked briefly today about the user tier, server tier, database tier. Probably not really going to show up much on the test. When we talked about protocols, we talked about HTTPS. HTTPS, the S stands for secure because that traffic is encrypted. Encrypted is like coded, right? So, if you ever used the decoder ring with your buddy when you were little, you encrypted. You said, here's going to be, 1's going to mean B, C's going to mean, 3's going to mean C, and we go from there. So we encrypt it, and then they can decrypt on the other end. The cloud, talked about the cloud a lot, manages and dismanages the cloud. And then we also talked about software, platform, and infrastructure as a service today. The other thing that we did go over that you will be responsible to consume on your own is the video that I provided for you. It's on YouTube. It is called Modern Marvels, the Internet Behind the Web. And it's really a good video. It's kind of an old video, but it talks about the history of the Internet. It's kind of neat to see the thing that our lives rely upon and how it came to be. So I talked a little bit about it coming out of DARPA, the Advanced Research Project Agency. But you'll see in that video some of the people involved, many of them are still alive, and how that came to be. And what I'd like there'll probably be at least 2, maybe 3 multiple choice on the test from that video, right? So you need to watch that video or you're going to miss 4 to 6 points. And so you make that decision. But what I'm looking for on that video are some, there's some names of some folks on there, like the guy that kind of invented the World Wide Web. Okay, probably an important name to know. The first killer application of the internet, which I think we've talked about before. What was the first? What's that?
Was it email?
It was. Yeah, you skip the video, you got one. So those are the things I want you to get out of there. So as you watch that video, I want you to take notes, and I want to show you where that video is right now. It is on Blackboard. You can Google it if you want, but if you go to Blackboard, under Course Material by Chapter, under Chapter 6, because it's related to the cloud, I want you to go to Modern Marvels, the Internet Behind the Web. Okay. And it's about a class period long. So that will, it's 47 minutes, that will suffice for Monday. So please watch that sometime between now and Wednesday. It will be on your exam. Any questions on Chapter 6? Okay, so the short answers, there will be 4 short answers of these 8. Okay, so and if you guys would like, it don't seem very playful today, but if you would like, we could lock in one and we can eliminate one. Describe the 3 types of software. I think that's pretty applications. I think that's pretty vanilla. We talked about horizontal, vertical, and one of a kind. Describe the 3 ways of acquiring software as described in your text. List an advantage and disadvantage of each and what that method and when that method is commonly used. Explain the difference between thick and thin clients. Describe some advantages of business growing by employing thin clients. What is the hierarchy of data? And give a brief example to demonstrate your knowledge. Explain the difference between foreign keys and primary keys and demonstrate a relationship in a relational database. Explain the various components of a LAN. Okay, that one slide kind of does that for us. Why would a business employ a database rather than a list spreadsheet? Provide an example when each would be appropriate. And what is the cloud? Give a cloud application or use, and what are some advantages and disadvantages to a cloud model? So those are the 8. First off, any questions you guys have on those 8? Is there anything that is not clear to you? All right. Would you guys like to guarantee one on the exam? No? 4 is nominated to lock in, right? Is that what you're saying, JJ? 4 is the hierarchy of data. Boss.
What kind of example are you looking for?
You know what would be good? Probably something like this. You could say, hey, here's a student table. Okay? So in the student table, we have, the student ID, we have name, so we put data in there, and you'd say, okay, this is the table, point to it. This is a record or row. This is a column. You could then circle in John Deco, the J is a character. That's all I'm looking for, right? That you know how those things come together, right? Something like that.
Everybody's sick or tired.
Oh my God. I'm a little sick too. I slap you guys with 5 kids and see how you're like.
That sounds like that.
It's fun, but it's like to be what? 3. Hey, I don't care.
3. 3's fine. Just log one of them.
It's unbelievable. Apathy. Apathy. Just apathy. You're pretty alert today. You sick?
I guess
Everybody's sick, right? Everyone's sick.
Yeah, my throat hurts too.
You power through it, right? My throat hurts too, and I'm up here talking. Popping cough drops, right? Power through it. All right, so 3 lock in 3.
Yeah, sure.
What else? We can eliminate 1. You don't have a class Monday or Wednesday. Oh yeah. I won't be here.
Fine. Well, that's something. I don't know, there's literally an entire sign. There's no reason to.
Well, you guys saying you're all awkward.
Yeah, I didn't sleep last night.
You didn't sleep at all? Not at all.
Why not? It's just one slide.
Couldn't.
There's only one thing to say.
Everything
That's
was
really what
good.
it is.
I tried.
Really?
Just didn't-
I sleep like a baby every night.
Yeah, last time there was like clear, let's get out of there. Who's the most awake? Someone pick something.
I'm so hungry.
Seconded.
Why?
I don't know, it might have been probably, but I would.
You all right?
Yeah, no, fine.
I didn't see you.
Have
Like
water,
Steve,
yeah?
you should just take over class. You're
Yeah,
like,
we
yeah.
designated questions.
You should just say like, all right, I got this for you.
Yes, you got it. Number 8 is gone.
All right.
8.
All right, that's fine. So what'd you say? 3's in, 8's out?
Yep.
3 in, 8 out. All right, I will once again not be here. I'm not telling anyone that didn't come today. They can show up Monday and find out. So
You got
no,
so much enjoyment out of that.
so yeah, no class on Monday. You do have to watch that video because it will be on the exam. It is really, it's kind of an enjoyable video. I know I'm a geek, but I think you'll enjoy it as well. And then Wednesday will be the exam. The GA will be here, and then Friday I will be back. Do we have? And then Friday I think we have some presentations. Do we have any more presentations left? I have to look at the doodle poll. I'm not sure. Okay, have a great weekend. Sleep, heal up. You're young.